Ever wonder why some things, like an explosion, happen in the blink of an eye, while others, like rust, take forever? Well, it's all about speed. Today, we're going to peek behind the curtain and find the control panel for chemical reactions, and I'll show you exactly how it works.
I mean, just think about it, right? You crack an egg on a hot pan and boom, breakfast is ready in minutes. But that old iron gate outside, it can take years to get properly rusty. They're both just chemical reactions, so what gives? What's the big difference here? The secret is something called reaction speed. And the really cool part is that there are basically 4 hidden dials that you can turn to control it. You can crank the speed way up, or you can slow it way, way down. So let's check out these dials one by one. All right, first up, we've got the concentration dial. And honestly, the best way to get this is to picture a party. For anything to happen, for a chemical reaction to kick off, particles have to collide. They have to bump into each other. So what do you think happens when the party gets more and more crowded?
Yeah, exactly. The more crowded the room, the more people are going to bump into each other, right? It's the same exact thing in chemistry. Higher concentration just means you've crammed more particles into the same space. More particles means more collisions, and more collisions, well, that means a faster reaction. So to see this for ourselves, we can do a classic lab experiment. We take hydrochloric acid at 4 different concentrations, so 4 different levels of crowdedness, and we drop a little strip of magnesium into each one. Then we start the timer. The big question is, which one dissolves the magnesium the fastest? And the result? It's not even close. The beaker with the highest concentration, our most crowded party, dissolves that magnesium strip way, way faster than the others. It's really that simple. You turn up the concentration dial, you turn up the speed of the reaction. Boom. Okay, on to dial number 2, the temperature dial. And this is one you already know intuitively. You put food in the fridge to make it last longer, to slow down the spoilage, right? And you put it on a hot stove to cook it faster. So what's actually going on there? Well, turning up the heat doesn't just make particles collide more often, it makes the collisions better. See, a higher temperature gives every single particle a ton more energy. So they're not just walking around anymore, they're sprinting. They zip around, hitting each other more often and with a lot more force. That extra oomph makes a reaction way more likely to happen. So, back in the lab, the experiment is super straightforward. We take 2 identical beakers of our acid. We put one in a chilly ice bath and the other in a nice hot water bath. Drop a magnesium strip in each and, you guessed it, we time them. And wow, the difference is just huge. The reaction in the hot beaker is crazy fast compared to the one at room temp. And the one in the ice bath, it barely even moves. It just kind of crawls along. So turning up that temperature dial gives the reaction an absolutely massive kick. All right, our third dial is one you might not have thought of before. It's surface area. Picture this, you're trying to start a fire. Is it easier to light a big, solid log with one match, or a pile of sawdust made from that same log? Which one do you think is going to burst into flames? The sawdust, right? Of course, because every tiny speck of dust is surrounded by air. Well, the chemistry version of this is comparing what happens when you drop some marble chips into acid versus dropping the same amount of finely powdered marble into it. So, how big a difference does just crushing it up make? You won't believe it. By turning those solid chips into a fine powder, you can increase the surface area, the number of places the acid can attack, by something like 1,000 times. 1,000! And just as you'd guess, the powder goes crazy. It fizzes up like mad and disappears super fast. Meanwhile, the chips just kind of sit there and bubble slowly. See, a reaction can only happen at the surface, where the 2 chemicals can actually touch. More surface area means way more places for the action to happen all at once. And that brings us to our 4th and final dial, and this one is kind of mysterious. It's the catalyst. The best way to think about a catalyst is like a chemical matchmaker. Its whole job is to bring 2 other chemicals together, get them to react, but it doesn't actually become part of the final product. It just sets them up. What it's really doing, scientifically speaking, is offering an easier path for the reaction to happen. It's like, instead of having to climb a huge mountain to get to the other side, the catalyst shows you a secret tunnel that goes straight through. It's a massive energy shortcut. And the craziest part is, the catalyst itself doesn't get used up. It can do its matchmaking job over and over again.
There's an amazing way to see this happen. We start with hydrogen peroxide. Now, on its own, this stuff breaks down into water and oxygen, but it does it incredibly slowly. So we'll take 2 beakers of it. Into one, we do nothing. But into the other, we add just a tiny pinch of a catalyst, a black powder called manganese dioxide. And the change is instant. I mean, it's so dramatic. The beaker with that little pinch of powder just erupts with bubbles of oxygen. The reaction is happening at lightning speed. And the other beaker? Nothing. It's just sitting there. That is the incredible power of a catalyst. So there you have it, our 4 dials: concentration, temperature, surface area, and catalysts. But look, this isn't just some abstract stuff for a chemistry lab. You are turning these dials every single day. No, seriously, think about it. When you use a concentrated cleaner to get a tough stain out, you're using the concentration dial. When you turn up the stove to cook dinner faster, that's the temperature dial. Even just chewing your food, that's increasing the surface area so you can digest it. And your car? It has a catalytic converter that uses a catalyst to make the exhaust safer. These controls are absolutely everywhere. So from now on, whenever you see something happening, whether it's super slow, like a banana turning brown, or super fast, like striking a match, I want you to think about those 4 dials. Which ones are being turned up or down? Because now you know the controls. You can see the invisible chemistry that's constantly at work, shaping literally everything around you.